Hey guys, okay, now I'm going to do my first full official test of 120 volt out of the wall into this 24 volt 1.2 amp current limited power supply. The problem with this power supply and why I need this guy here, the DC-DC converter, is because when this guy gets to 1.2 amps, it's still drawing and it goes shuts off and then turns on and up to and then shuts off. So that's current limited, not current controlled. But this one's current controlled. I've got it set for 24 volts, 1 amp max. That way it never maxes out this guy. But I also have it split out. Its output is going in two directions. We got it going out to here, our regular feeds are positive and negative to power the transistor, but we also have it split into this buck boost converter, and I can't take 24 volts into our Hall effect sensors. They take about 3 volts or so. So I've got this guy set to about 3.5 volts, and we'll be able to see that voltage come up here. So for now, the scope is set to the base and the collectors. We'll see a bunch of stuff there. That's the current voltage that's in the capacitor bank. And so let's turn it on. Let's see what happens. Got power. Oh, we got movement. Do we have enough on the trigger? That's a question. We're pulling 2.5 volts, 2.5 volts here. We're not pulling any amperage through here basically, it's just a little bit on the trigger. So let's juice up the trigger, and then that should allow more juice to flow here. I'm just making. Okay, so let's tweak this up. Are we on the spot? Not even on it. Hold on here. Ah, get in there. Alright. Tweaking it up. Oh, going down. Other direction. We'll give it 3 full volts. Alright, should be that. And we're seeing we're not seeing any amperage pass through here. So is all of this connected? Good. And black leads going here. She's trying. She's trying. 1.69 is back up here. Let's see what we see here. A little bumpy. I think it was feeding at 5 volts before. And see, it's sort of pulsing. Let's give it more. 2.8. So 3.5. No, it's not. It's dropped. Okay, let's see what that does. 3.5. Not pulling on the amps, but we're getting a much stronger output here. So what's going on? The light's on. Why are we getting this weird pulse? The amperage is really low. The buck boost converter is doing its job. The trigger is definitely going on and off. Getting close. I'll solve this tonight. Alright, wish me luck.
A few moments later.
Okay, after a little bit more poking about, figured out the problem was partly to do with this guy, this buck boost converter. It wasn't sending enough voltage through to the Hall effect sensor, which was not sending enough information or enough digital information or voltage to the base on this transistor in order to turn it on and allow it to flow energy from this guy, which is also going through this. So this supplies the energy. Let's see, we're going 120 or 110 from the wall through this line, this coil. Then we're taking it out of there. So we're getting power from the wall. This is a 24 volt power supply with a current limit of 1.2 amps. But it's not current controlled. So when it gets up, when you start drawing more than that, because this system could take it and it will just run with it, it spikes up on the amperage and then dies. Up and then dies. Up and then dies. So that's not good. So I have this DC to DC converter, and this allows me to set it at a specific voltage and a specific current, so it won't go above a certain current. It'll run up to whatever voltage it can, but the current will be the limiting factor in that. So this is current controlled. However, out of this guy, I then need two things powered. One thing is it comes down these lines from here on all these splits. It comes out to here to this buck boost converter, which allows me to set from like, I don't know, 1.2 volts up to 36 volts. And I use this guy to control the amount of current that's making it to this from here. And so this is the Hall effect sensor. So it requires really about 4 volts maximum for optimal capacity and for sending a strong enough signal to the output to trigger that guy on and off. So we'll be able to see that here when we turn all this on. The other direction it goes is it just feeds the negative and the positive feeding into the emitter and out the collector, which then causes the pulses on these guys. So you can see that this is turning. So we're just going to stop it. There's nothing going on there. That guy there is the voltage currently in the capacitor bank collecting the back EMF. The oscilloscope is connected, and we're going to see what's going on with the base and the collector. So let's just turn it on. Okay, boom, we've got power, and we already got movement. You can't see it, there it goes. And you can see the oscilloscope's coming up. You can see we've got 16 volts being passed through, so 24 volts is being released by this. So it's taking a 120, turning it into 20 or 24, and then this guy is dumping it into here. We're only asking for 16, but it will push up to 1.1 amps. Pretty sure this is how this should work. In order to make sure this guy stops current limiting, we're going to current control on this one. And then it splits it out, feeds this guy with 4 volts, that feeds this guy. You can see the Hall effect sensors going on and off. And then that is triggering on the output trigger, the transistor, which is then allowing energy to flow between the emitter and the collector of the collector, and then into our various coils. Out of our various coils, when the back EMF collapses, it hits this diode, where is it? Right in here, if you can see it. And then it flows backwards through all this spaghetti into the capacitor bank here. So we can see what kind of amperage is going in. Right now it's super low. Basically nothing, because this is really too slow. The voltage is 3.541. We may see it creep up, but it'll be very, very slow with this amperage being so low. So right now we're dividing it, so we're using the 0 to 0.6 connector. So that means it's going to use the bottom side here. So right now it's not even putting out like 10 milliamps with the back EMF. So we did go up. 0.1 went to 0.7 already. Whatever, it's going up. I can't see it, but it is going up. Once our voltage and our amperage is like really, really low, I mean, you couldn't even shave with this much. This wattage is ridiculous. I think I could get the wattage on the interface here, the switch. There's the wattage. It's 5.6 watts. For most modern shavers, you need about 20 watts. So this is, I don't know, maybe peel an apple or something. Any rate, amp hours, 2 minutes. And so here's our amperage. So less than 400 milliamps. Let's see what our RPMs are and if we can increase all of this. So we've gone up a little bit more on the voltage, still climbing. Still don't see anything on the amperage output here though, but it still says it's going up. It's gone up again. So let me get the, here it is, tachometer. Let's see what we got. It was probably about 500 RPM. Oh boy, I was really close. 500. So can we make this faster and make all this more efficient? Still going up. Still nothing on the amperage. Still weird. So let's see if we can increase this at all. So we need to do this button here. Right, so it boosts the voltage. Okay, this requires a lot of cranking. We'll go to 18 volts. Alright. That allows us to adjust the amperage. We don't need to change that. Okay, the milliamps have gone up. I can hear it speeding up. So our trigger is still about 4 volts. So that's what's going into this guy. Our amperage, our voltage is continuing to rise a little bit faster now. And we can see the amperage's needle starting to move. Statin. Just statin. See the power still coming from the power supply. And I can hear this guy speeding up. So let's see what we got. Yeah, I went from 500 to 550. Let's try more. So we're at 24 volts here. Current limited here. Let's change the voltage. I think we could just turn this dial. I can't remember. Yep. Alright, let me go to 10 here and then we'll do it by tens. Alright, so now let's do this one. Okay. Let's go to, I don't know, 21 volts, because that's what our capacitor bank's going to be at eventually. Same amperage, but it's gone up. So more is being allowed to flow. All that's good. Voltage is going up. So that's back EMF collected into the capacitor bank. It's going into there. Our amperage has also gone up. Power still coming from here. Nothing's adjusted. Just this is at 21 volts now. So we're at half an amp basically, floating below half an amp. Still full volts. 4 volts. Can't speak. On the trigger, and everything's happy. This amperage is what's going into the trigger. So we got 4 volts going into it, but it's like, that's the amperage going into the trigger. So that's like, I don't know, 5 milliamps. Oh, actually, no, I know what it is. I think it's 1.2 to 5 milliamps. It's really low. It's just, you don't need a lot of amperage for that guy. But if you go too high, you go like above 5 volts or something, she dies. I've killed a couple of chips over here already. Those two. So I've ordered 5 more. So what's next in this series? I have a trigger coming that will allow me, not sponsored by Coke. Let's see here. What do we got? So this is a look at our circuit. One of the things in there is this guy. So my intention with this is to be able to take the back EMF and pump it into here, and then parallelize it across another 24 volt capacitor bank. This acts as our source, then sending it into this trigger time delay. So we're going to run the whole system for about 5 seconds, and then turn off for maybe 8 to 10 seconds. But when it's on, it'll go into the DC buck boost converter, and then that'll go to the Hall effect sensors after it goes through. This is one place here is I'm missing the buck boost converter that's right here. Then that will trigger on the transistors, which will then trigger these guys here, sending energy through all of this, but being collected in two different ways. One is we're going to have a on-off on toggle switch, a latching switch, at each one of these coil sets. So each Hall effect sensor gets its own power, and it powers an individually separate transistor, which powers an individually separate set of coils. So each coil set's 2. So there'll be 2 coils here, 2 coils here, 2 coils here, for a total of 6. But it also means I won't be powering all 6 at the exact same time simultaneously, because I'm going to do an offset. I'm going to do 4 coils and 3 magnets. Yeah, that's right. The other way around. 3 coil pairs, 4 magnets rotating, which will allow only one set to go off at a time. So only this will go off, and then this will go off, and then this will go off, and then this will go off. It'll repeat. But what will happen here is we will allow energy to flow down from the transistor, go through the coil, then the transistor will turn itself off because it's no longer at the right position for the magnet, and then the back EMF will flow this way and go, oh, I can't go that way. So it'll go into here, go into the center of this little pin here, and then if it's latched this way, it'll flow out this top part here. So back EMF, negative back EMF will be able to flow here, then here, it won't be able to go in there, and then here, it won't be able to go in there, and then here, and won't be able to go there, and then eventually wind up here. Positive back EMF, I meant to say. Sorry, that's a positive diode. And the same thing will happen with the negative on this one. The way I've printed this out makes it look really weird. These lines are not in the diagram when I drew it out, so they're kind of goofy looking right now. But we could also have these guys latch the other way. So we have the latch set to this side, which means these pins get activated, which will allow me to just run the magnet past the coil without any of this stuff turned on, and it will generate energy. So I'll be able to put a hand crank on this thing. The flow will be a sinusoidal waveform which will flow into the center, and then latching will send it down these corridors here into this rectifier on either side, and it will come up positive on one side, and it won't be able to go in there, so it won't be able to go in there, and so it will go in there. And so we can actually use this as a generator to power itself. So we don't need to plug this into the wall, we just periodically will need to give it energy. We'll fill it up here, and the back EMF will come here, and the time delay will actually allow it to be more efficient and delay the whole thing. So it doesn't have to all go in one shot. And of course, the bigger that you can make this guy, the longer the whole system works. It's not over unity, it's efficiency. This is a truly efficient electromagnetic pulsing machine, I mean, we're feeding it, what are we actually feeding it? 21, so that's half of that, so it's, 11 watts? Or I can find it here, hold on. Oh, not even, 9 watts. I still need double that to power a shaver, so not bad. Not bad. And, if all that works, then when all this is finished and this circuit is fully built out and fleshed up and the capacitor banks, I got the right sizing and everything in here, maybe I'll add like 3 or 4 more of these, the 21 volt. They're actually really, really small. They probably won't last very long. That's these guys. Yeah, warnings, okay. I don't know why they do that. Put them on the wrong side. 2.7 volt. And there's 8 of them in this cap bank, which is really unusual. Normally you see them at 6. I was thinking of building my own, but then I was like, oh, I need a protection board on them, and I don't know. I'd rather stick with the protection for now, and I'll experiment with non-protected capacitors down the road. But that's where we're at. Things seem to be working well. I could feed a little bit more voltage into this. We'll probably get more speed. We'll have one last look at what we've got right now. Yeah, 650 RPM. So not bad, not bad. I'd rather have double that in RPM, and we were getting that when I was doing a direct pull of electricity from this guy, but it was pushing in 1.5 amps And if we want to go through this guy for the higher voltage, because that's only 15 to 16 volts, so this is up to 28 volts, and then I can current control and voltage limit and all that other stuff with this guy, then I have to go this route. So, okay, anyway, that's where we're at, guys. So far, great success today. Wish me luck. See you in the next one. Bye.